Flack math! Give me some math and I'll give you some flack. Flack math!
So making graphs and solving equations of circles. I'm surprised they waited this long to do this, because these equations are on a lot of tests as well. So first of all, let's talk about conic sections. So if I had, and when I talk about conic sections, I'm talking about if I were to cut some things out of this, if I were to take a piece of paper and cut it right there, well, that section that I cut would be parallel to that circle, so it's a circle. But if I angle it at all, do you know what that is? An oval, or an ellipse is what the technical word for it is. Okay, and then what if I did this? You guys know what that is? No, think about it. No, think about it. What does that look like? I went shave that off. It's a parabola. You see that? Yeah, it's an arc. So here's a parabola pointing up. See that? So if I cut it off, it would look like that. Isn't that interesting? Okay. So that's a parabola. If I did this, if I cut it right here, this is like two parabolas like that. This is called a hyperbola. It's not a hyperbola, which a lot of people say, but this is a hyperbola. Okay. But a parabola is just one of those. So that's pretty interesting. Okay, but going back to circles, the formula for a circle, did we talk about this yet? Circle formula? Maybe not. It's basically x squared plus y squared equals r squared. Okay, so this is the mother circle. So for example, on a unit circle, so x squared plus y squared equals r squared. If this was 1, that would be 1. So if you were to just plug in points, it would be a circle, okay? So if the radius was 1, then this would what has to equal 1? Well, all these points would equal 1. 1 and 0, 0 and 1, -1 and 0, 0, -1. But all these points in between, when you plug it into that formula, it equals a circle. All right. Now, here's technically the circle formula. And I forgot what letters they use here. Just kind of winging it. Yeah, x minus h. So this is like a shift, right? Squared plus y minus k squared equals r squared. Okay, so this is where the center of the circle is. The center is at h comma k. All right, center is at h comma k. So it kind of makes sense because you shift right that far, but over here, since it's inside the parentheses, you're going to shift right k units. All right, so if that was an actual positive number, you'd go the other way, and so on. So let's do an example. Example, here we go, 2 x plus 2 squared plus y minus 1 squared equals 9. Okay, so real easy. Here's my coordinate plane. Where's the center? Okay, close, but right, -2 comma 1. So blip, blip, blip. There's the center. What's the radius? 3. It's the square root of that. Okay, radius is Square root of 9, which is 3. So basically, you can do this. 1, 2, 3, 1, 2, 3, 1, 2, 3. Put some points there. And then, oops. Goes right there, right there. And then do your best circle. Okay? I do better circles when I don't have the dots, but that's it. That's pretty simple, right? Okay. Example 3, writing the equation of a circle. All right, so basically you have to get it in this form. Okay. So here's example 3. And it says, write the equation of a circle with center -3, -1, and radius 7. Oh, easy. Center is -3, -1, radius equals 7. You can do that in your head. What's the equation of this circle?
X plus 3, and then y plus 1, radius 49.
Yep, just square it, you're done. Okay, so see how this is just like x squared plus y squared equals r squared, but you're shifting left 3, left and down 1. Okay, that's pretty easy, right? All right, now it gets a little tricky. I think maybe next unit or the one after, we'll have to do something with ellipses, which are a little bit different because they have 2 different radiuses or 2 different radii, because they have like a fat one and a short one, right? Ellipses have like a shorter radius. If they were both the same radius, it'd be a circle, but they have a horizontal radius and a vertical radius. Did that backwards. Okay. Let's do one more example of writing the equation of a circle. It has a diameter whose endpoints are located 3 and 1, 6 and 3. Okay, so this is what they give you. They give you a diameter of a circle, and they give you the endpoints. One of them is at 3, 1, and one of them is at 6, 3. 3, 1, 6, 3. 1, 2, 3, 1, 4, 5, 6, 3. Okay, so here's the diameter of the circle. That's kind of weird because it's a diagonal line. So the circle would probably be like this. Okay, well, how do you find the center of that circle? You guys remember doing this? How do you find the center of that circle? We did it in geometry. Well, you could probably use your best guess. But the center is halfway between the x's and halfway between the y's. So the center is going to be the average of the x's. So 3 plus 6 divided by 2, which is 4.5. So the center is 4.5, comma, and then the average of the y's is 1 plus 3 divided by 2. So that's 2. Okay, so far we've got this equation. X minus 4.5 squared plus y minus 2 squared. You guys okay with that? That's the center. Equals, now how do you find the radius?
It's half the diameter.
Half the diameter? How do you find the diameter? Do distance formula if you want. Okay, distance, difference of y's squared, difference of x's squared. So let's see here. That's 3 squared plus 2 squared. So 9 plus 4 is 13. So that's the square root of 13. So what's the radius? Cut it in half. Okay, but then this is all going to be squared, right? So final answer. Instead of doing that, you can just write 13/4 is the radius squared. See how I did that? Okay. Just raise your hand if you're slightly bummed that you don't have to be tested on this, because it seems easy. I mean, let me rephrase that. If you're slightly bummed that you don't have to be tested on this, but you had to be tested on more difficult things, yes. Because this is pretty easy so far. Okay? All right, so that is 91. I don't know why I say raise your hand. Even if you did, you wouldn't raise your hand. You guys don't like to raise your hand. It's okay. 92.
You died.
Excuse you. Dude, go to the bathroom. All right, moving on. Here we go. So this is finding arithmetic sequences. Okay, so we're going to complete the table here, and we're just going to try something. Yeah, I don't think we need to do that exploration. Let's just start with example 1. Okay, identifying and using the common difference. Okay, you guys did this in like Math 8-7 or Algebra 1/2. But here's the sequence: -14, -9, -4, 1. Okay, raise your hand if you're bummed that you weren't tested on this.
I had a question like that on the ACT.
Yeah.
Where it was like, which one comes next? You're like, okay.
So what comes next?
We positive 6.
Yeah, you're just adding 5 each time. So apply the pattern to get the next one. Okay. Okay, so subtract a term for the term. Yeah, okay. The next 3, so it says the next 3 terms. So you might have to add 5 a couple more times if you can handle that.
Oh no.
Okay. All right, so next thing is an explicit formula. This is a definition. Explicit formula. It sounds like dirty, doesn't it? Explicit formula. It's like explicit lyrics or something. Defines the nth term of a sequence in terms of n, meaning that the nth term can be found without knowing the previous term. For the arithmetic sequence 10, 14, 18, 22, 26. So here is this defines the nth term in a sequence. So let's take this sequence, for example, 10, 14, 18, 22. Okay, so what are you doing in this sequence? You're adding 4, right? So the A of n is going to be basically, you're going to start with 10, but then you're adding 4 times. So if you start with 10, then you're basically adding 4n more times. Okay, 4n. So you can try it with just a couple samples first. Before you get the explicit formula, you can go, well, a to the first term is just 10 plus 0. A to the second term is going to be 10 plus 4. A to the third term is going to be 10 plus 8. A to the fourth term is going to be 10 plus 12. What are you doing? What you're adding is being multiplied by 4. Okay? So a to the nth term, not to the, but the nth term is going to be 10 plus 4 times that number. Okay? All right. Let's try an example. Find the nth term of the arithmetic sequence. Here's the arithmetic sequence. So this just says find the 15th term. Okay, so we're going to find the nth term first and then apply it to the number 15. So we got 4, 15, 26, 37. What are we doing? Adding 11? So the nth term is going to be 4 plus, what is it? 11 times n. Agree with me? Okay, so the 15th is going to be 4 plus 11 times 15, which is 4 plus 165, which is 169. Okay? Pretty easy, right? All right, moving on. Finding the nth term given any two terms. All right. So this is example 3. Find a of 1 of an arithmetic sequence given that a of 1 equals 34 and a of 16 equals 61. Okay, that's weird. So this is example 3. A of 1 equals 34 and a of 16 equals 61. Any guesses on how you do this? Well, good guess, but a logarithm is just mostly with exponential equations. But we're multiplying. This is linear. So basically, let's just write our formula. A to the n equals our first one, which we already know is 34, right? Plus something. Well, how do you figure out this number, this 11? And how do we figure out this number, this 4? How do we figure those out? What do we do? How do we figure that out? How do you figure out that this is 4 and that this is 11? What'd you do?
Found how much was added.
Yeah, so in between consecutive members of that sequence, right? So basically we've got, did I just copy that down wrong? I'm sorry. Okay, so this is actually the 7th. So this is a of 1, okay? But so we don't know that that's 34 yet, right? It's not 34 because it's the 7th term. It's not the first term, okay? All right. So to figure out the distance, what we could have done is if I wanted to figure out the distance between, or the difference between 15 and 37, then what is that? Well, that equals 22, but it's 2 members apart, right? So if I did that difference divided by how many that is, well, let's see if that works. So this is going to be a to the a of m, or a of n minus a of m. Okay? So a of n is basically that last, the last term, and then a of m, it could be like the one in between it. All right? So let's just replace these guys. So let's go a of 16 equals a of 1 plus a of 16 minus a of 7 times n. Okay? Well, we know those numbers. This is 61 equals a of 1 plus 61 minus 34 is 27. n. Okay? What did I do? No. So this is not 61 minus 34. This is just 16 minus 7. Okay, so 61 equals a of 1 plus 9n. Okay, and sorry. Here's what we could have done. Because really, like, see, this, you didn't think that these sequences would be that difficult. It doesn't have to start at the beginning. So this is our a of m. Okay, so that a of m is 34. Okay, so now you can solve for n. So 9n equals 27, n equals 3. Okay, so a of n. So that is our, basically our, not n, why did I put n? It's like our, this isn't n, it's like our, basically how it differs. It's like a, we'll call it b. Sorry, this is confusing. Good thing you're not tested on it, right? Okay, so to find the nth sequence now, a of n equals a of 1 or plus 3n. Okay, now find a of 1. So we can figure out a of 1 by just plugging in values here. So I could just pick like 61 here. So I could say 61 equals a of 1 plus 3 times 61 was the 16th. That's 48. So a of 1 equals 61 minus 48, which is 13. Sorry, 16 minus 1. Oh, this is a mess. I'm sorry. All right. Well, if you want to remember something, you can remember this formula. This is a nice one. This, if you're given two numbers in a sequence, I didn't think it was possible to try to figure out what the sequence is if you're just given two random numbers, but now you have a formula that allows you to do so. Okay, that is basically it. The next problem is the same thing using the same formula. Okay, so that's it. Good job. Any questions?
Black man, give me some math and I'll give you some flack.